Okay, hi everyone, welcome back to this video series on Cisco Packet Tracer, IPv6 on Packet Tracer. IPv4 has 4.3 billion addresses, which may seem mind-boggling. However, it took only 2 decades for it to reach its depletion. IPv6 has come to the rescue in the form of 128-bit addresses. Packet Tracer supports a wide array of IPv6 features. We'll start by learning how to assign IP addresses to different devices and how to configure routing between them. Finally, we'll create a setup that enables IPv6 communication over IPv4 devices, assigning IPv6 addresses. Starting from Packet Trace version 6, the IP configuration utility under the desktop tab of end devices has an option to enter an IPv6 address. Let's begin with a simple topology consisting of 2 PCs and a router connected to a switch as shown in the following screen. There are 3 ways of assigning IPv6 addresses to a device, and we'll see each one of them. Auto-configuration. Auto-configuration requires the least amount of configuration, but it makes it difficult to remember the IPv6 addresses. This method uses the MAC address of the device to create an IPv6 address with FE80 : prefix. Carry out the following steps to assign IPv6 addresses using auto-configuration. 1. Begin by configuring the router. Enter the interface configuration mode and enable IPv6 on the interface. Or 0 config IPv6 unicast routing, or 0 config interface fast Ethernet 0/0, or 0 config if IPv6 enable. 2. Next, we'll configure a link local address and a global unicast address on this interface. We'll use the EUI64 to reduce the configuration, or 0 config IPv6 address auto-config, or 0 config if IPv6 add 2000 : /64 EUI64, or 0 config no shutdown. 3. Verify that the interface is up and has 2 IPv6 addresses, or 0 SH IPv6 interface brief fast Ethernet 0/0 up FE80 : 2D0:58FF FE65 : E701 2000 : 2D0:58FF FE65 : E701 4. These IPv6 addresses may vary when you try them out, as they are based on the MAC address. Enable routing so that this router can be identified as a default gateway. Or 0 config IPv6 unicast routing. 5. The configuration of the router is now done. Let's move on to the PCs. Go to the desktop tab of the PC, open IP configuration, and under the IPv6 configuration section, choose auto-config. The gateway and the PC's IP address will be assigned automatically as shown in the following screenshot. Using this simple PDU tool to test connectivity, you'll see ICMPv6 packets moving between the nodes. To view the IPv6 addresses from the command line of PCs, use the IPv6 config command. Static IPv6. IPv6 addresses can also be assigned statically in all devices. We'll use the same topology for this section too. We'll carry out the following steps to configure IPv6 addresses statically. 1. Begin by configuring a static IPv6 address on the router, or 0 config interface fast Ethernet 0/0 or 0 config if IPv6 enable, or 0 config if IPv6 address 2000:1/64 or 0 config if no shutdown. 2. Go to the desktop tab of the PC, open the IP configuration utility, and enter an IPv6 address with the same prefix. 3. Now use the simple PDU tool to test connectivity. Once both the methods work fine, you can have a look at the IPv6 neighbors table. This is similar to the ARP table of IPv4 or 0 SH IPv6 neighbor. IPv6 address age, link layer A DDR, state interface 2000:000E0.A39E0.05C4 reach FA0/0 2000:030:1.43B9.0268 reach FA04/0. Now that we have configured IPv6 addresses on a single network, let's configure them on more networks and enable routing between them. IPv6 static and dynamic routing. Similar to IPv4, IPv6 supports both static and dynamic routing. Configuration commands for its static routing are similar to IPv4. Static routing, modifying the same topology that we used previously. Let's add a router, switch, and 2 PCs to create a separate network as shown in the following screenshot. The first network will use the address starting from 2000:1:/64, and the second network will use the address starting from 2000:2:/64. The link between both the routers will have IP address 2001:10/64 and 2001:20/64. Here is a table describing the topology. Device interface IP address or1 fast Ethernet 0/2000:1:1/64 fast Ethernet 0/1 2001:10/64 PC 0 fast Ethernet 2000:1:2/64 PC fast Ethernet 2000:1:3/64 or 2 fast Ethernet 0/0 2000:2:1/64 fast Ethernet 0/1 2001:20/64 PC 2 fast Ethernet 2000:2:2/64 PC 3 fast Ethernet 2000:2:3/64. After the necessary IP addresses and gateways have been assigned, open the CLI tab for the R1 router and start configuring routing by following the given commands. R1 config IPv6 unicast routing, R1 config IPv6 routing 2000:2:/64 2001:20. Next, open the CLI tab for R2 and configure routing on it. R2 config IPv6 unicast routing, R2 config IPv route 2000:1:/64 2001:10. Now use a simple PDU tool to test connectivity. You may also use the tracer command on a PC to see the path a packet takes. PC tracer 2000:2:3. Trace route to 2000:2:3 over maximum of 30 hops, 164 ms, 63 ms, 47 ms, 2000:1:1, 294 ms, 78 ms, 94 ms, 2001:23, 156 ms, 109 ms, 129 ms, 2000 :2:3. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.